Okay, so in this video I will show some new features that I have been adding on this firmware and on the tool. So first we can connect on the device and we get these parameters. We can go to this tab and I will change this HFI mode, this pulsating HFI like that. I will write it again. So now it has this 18 kilohertz. So we can go. Let's see. So we can go here. I will plot this measured IQ current and then the commanded IQ current. It's here. So we can enable the driver. Now it's doing this HFI thing. And then we can set the step time and let's say like 2 amps here. And now the motor will start running this kind of thing. And this is basically the step response. And here it's trying to run this 2 amps, first positive 2 amps and then this negative 2 amps. But on this mode it's not using the PID loop, it's only using this kind of like feed forward. So we can then check what happens when we go and active this. So now the PID loop is enabled and it gets much closer here to the target, but we can still see that it's not getting to the target as it should go. So we can let that run. But we can go here, and this is the new thing I have been adding. So here we can have basically any parameters for any motor and then we can calculate these gains. And these parameters I have been using this calibration methods to get those. So we can see what happens if instead of 100 Hz we go this 250 Hz. So we get these new parameters, so they are basically like optimal for this kind of PI control. So it's using the resistance and this inductance on the D and inductance on the Q axis, and then it will calculate these gains. So we can write those, and now we see the motor is acting a little bit more responsive. So it's almost getting to the target, but it's still not there. And we can see like how it's raising the current there and trying to keep it, but it's still not able to get it there. So then we can go even higher. So let's try 500 Hz. And now we can hear the motor is making more that clicking noise because it's getting the faster speed. And now it's getting pretty close there, but it's still not that close. And we can even run like 1 kHz bandwidth. And then if we check with this, now it's starting to like, it's very good. So it's trying to drive it to the 2 amps and it's actually driving it there. And I haven't tried, but I think we could even go higher, so like 1.5 kHz. This is already like very high. Let's see what happens. So it can even do that. So that just means that it's even more responsive, but that 1.5 kHz, it's very fast. It's like something that is used for robotics, and this is like it's getting it very fast, and it's all completely sensorless, so it's only using this silent HFI. and we can even plot the HFI here. So this is the estimated rotor position based on the HFI signal. And let's see, I think we can even plot the HFI amplitude. So we can see that when we run this fast PID loop, there is still something to optimize. But with that fast PID loop, it's showing the when the current changes from negative to positive, it has this kind peak on this amplitude. And what the HFI control is trying to do, it's trying to keep this at 0 always, this amplitude, but we can see that there is some spike, so it's not fully able to do that, but I will try to fix that to get it even better. But then I think if we, so now we see how it's on that 0. I think if we go very lazy tuning like 100 Hz, let's see. So with that slow, there is not those spikes anymore. But I think those spikes doesn't even matter that much, but it's something nice to optimize and make it better. But I think that's about the tuning, and you can use this tool for also other motors. You just need to fill the parameters here, so it could be from some other motor like 33, and this could be like 100 or something, and then you just click the calculate gains and it should give them there. I think I had to write them first. Let's see. Was it so? Okay, so it's changing that there. I just didn't notice. Yeah, so it's working correctly. It's changing this one, and this one is changing those KP values. So this one says, yeah. But that's how the tool works now. Some new thing I'm trying to add also is this firmware update from this web tool. But this step response is very nice way to test how the motor works, like on some very fast responses. And one thing I can also show, did I do something? So we can go, what did I do? So now this is off. I think this was 50. Yeah, I think it was 50. But we can also change the frequency if we want. So we can go this kind, so we can even make some sounds with this. Yep. Yeah. Thank you for watching.